Hello everybody, this is Todd Frazee again, and now we are doing the S60-113 CAD portion, primary piston shell. You should do this in sequence right after the test tube. Very similar part, although this is made of brass, and will ultimately have other parts soldered to the end to make it a enclosed volume. But the procedure you use to make this component is identical to how we did the test tube. So if you haven't done that, part number 103, please do that one first. I'm going to go a little bit faster on this one. Okay, we're gonna open our CAD file. Okay, so here's the drawing for our primary piston shell. It's made out of brass, and we've got some pretty good dimensions here. So we have a 30 thousandths wall thickness typical, and we have a spherical radius of 0.26. Now we notice in the side view we also have a diameter, so we want to use the tighter tolerance number for our modeling. This has been rounded off. Sometimes this type of feature is hard to make on a manual lathe, so they've given you a little more liberty on the tolerance of the nose and tolerance on the inside wall thickness, except for the very first few bits, because that's where another part solders in. So they want the tolerance a little tighter there, but we're going to model everything at these tighter numbers. Okay, so we're going to go over and we're going to start our sketch, and we're going to do this pretty much the same way we did the test tube part. Okay, so we're in SolidWorks. We're creating a new part file. Okay, and we're going to make it in the primary view the same as what was on the drawing. So let's make our planes visible. We're going to do a sketch. We're going to do that sketch on the front view. We're going to make a 3-point arc from origin. And then we'll make our second point vertical, drag to the left, and have it terminate on the other plane. So this is somewhat constrained. And we're going to take a line and we're going to put it on the end of there, and we're going to go tangent and horizontal. So I've already got those relations there. Okay, and now we can go back to our drawing and throw a couple dimensions on. Well, let's give this thing wall thickness. So if we go back to our drawing, it's a 0.512 diameter. Okay, so let's go back to SolidWorks, and I'm going to make this radius 0.5125, and we're going to divide that by 2, and that gives us our radius. Okay, so this set of lines is now fully constrained, except for the length. We're going to hold off on the length. We're going to go offset, and we're going to go 0.3 for 0.03 for 30 thousandths wall thickness. And we'll select our chain. Okay, so now we have our wall thickness. Then we connect our endpoints. Okay, so now it's all shaded in the center, which tells us it's a full loop. And now we're going to create what we need for our revolve as a center line. So let's go from the endpoint there. We want a horizontal line, and we're going to make that point coincident with the end of the tube. Now we need to give it our overall length. It's the last constraint, because the length of this can change right now. So we go back to our model, or our drawing, and it's 1.4 in length. We measure from the end point of the nose to our vertical line here, 1.4. There we go. Our sketch is fully constrained. There's no longer a little negative symbol by it. We're ready to revolve this. Alright, so we'll go again to a 3D view so we can see what's going on. And we're going to go Features. We're going to do a Revolve Boss or Base. It's kind of auto-selected everything for us because we had it highlighted. So it figured out that our revolution center was that sketch line. We want 360 and it goes all the way around. I'm going to select OK. And there we have completed the -113. So pretty easy. Pretty much the same thing as you did on the last model, which should have been the test tube. You can change the material on this to brass if you like, and make sure you submit your file on time.